Good morning, all of you. In the last lecture, we have introduced the concept of regression analysis, its various types, along with regression lines, population regression line, sample regression estimates, then regression equations. Okay. Today, we are going to consider the regression equation using normal equations. Let us consider that is a simple linear equation model, that is y is equal to alpha plus beta x plus e, that is error term. So here alpha and beta are the unknowns, but it is generally known as it is the fixed parameters, and these are the regression coefficients. So alpha and beta are known as it is the intercept and it is the beta is the slope coefficient. And here E is representing it is the random error term or it is the disturbance term, which is generally representing all other influencing factors of y which is not captured by the variable independent variable x. So this model is known as linear population regression function, and in this particular model it expresses how the dependent variable y is related with the independent variable x for the entire population. Since we know it is usually cannot observe the entire population, the alpha and beta are not directly known. They must be estimated from the sample information. So using the sample of n observations, see here, so using the sample of n observation, that is x1 and y1 or x2 or y2 up to xn yn, we are going to estimate alpha and beta using the least square method. Least square method is a technique that minimizes the sum of squared residual. And the estimate of parameter are generally denoted by it is y hat, which is equal to alpha hat plus beta hat x. See here, alpha hat, which is the estimated intercept term, and the beta hat, it is the estimated slope. After estimating these parameters, we get the sample regression equation, which is generally called it is fit regression line. So this is the fit regression line, that is y hat, which is equal to alpha hat plus beta hat x. So this is the line that is the best fit for the sample data in the least square sense. So here y hat, which is the predicted or estimated value of y for the given value of x, and alpha hat, which is the predicted value of y when x is equal to 0, that means it is the intercept term. And here we can calculate the error term, that is E, which is equal to y minus y hat. It is the y minus y hat, or it is the residual, that is the difference between observed and the predicted value of y. See, now for the given n pairs of observation of both variable, that is x and y, we would like to determine the symbol regression in such a manner that is close as possible to the actual value. So here we have already explained this particular diagram in the last lecture. In the x-axis we are considering the independent variable, and y-axis we are considering the dependent variable, and this is the estimated regression line, that is y hat, which is equal to alpha hat plus beta hat x, and the slope of this particular line, which is captured by beta hat. And the difference between the vertical difference between these 2 points, which is representing actually the error term, so that is the difference between y and y hat. And then the alpha hat, which is equal to it is the intercept term. Okay. Now see, in this diagram, which is the simple linear regression model, which explain the relationship between independent variable and the dependent variable using this particular straight line, which is called the regression line. And this line is actually used to predict the value of y for every value of x as well. So here we can say that this y hat, which is equal to alpha hat plus beta hat x. Okay. And here the error term that I have already told you, it is the vertical distance between the actual value and the regression line which is marked by the error term. So this is represent the difference between the observed value and the predicted value. So E is here, it is equal to y minus y hat. It shows that how far a particular observation which is actually deviating from your regression line, that is how much your model is failed to predict failed to perfectly predict your y. So this is the regression plot help us to visualize how we predict y from the x. So the line minimizes in such a way that the sum of squared vertical distance between the observed point and the line should be smaller as possible. So that's why E is equal to, I am rewriting here, y minus, instead of y hat, what is y hat? Which is equal to alpha hat plus beta hat x, y minus alpha hat. I am going to open this particular bracket, so it will become, see, y minus alpha hat minus beta hat x. Now, see, the regression line should be fit in such a way that the summation of the squared residual should be minimum. That is, the best method is to fit the line, that is least square method. So consequences of this, that is, it is quite possible that algebraic sum of the E should be, the algebraic sum of this E should be small or even 0. So although E is widely scattered across the samples, we can avoid this particular problem if we adopt a least square criteria. The error term can be fixed in such a way that the sum of E square, the sum of error square should be equal to, that is the sum of y minus alpha hat minus beta hat x squared. Okay. Now, see, here we are considering that the sum of E square should be minimum with respect to alpha and beta. Now, considering this, we are going to use generalized power rule of differentiation. Since we are considering more than one variable here, see, we are going to take the partial derivatives here. Since the generalized power rule, if we have a given function, that is y is equal to f of x whole raised to the power n, then by using the generalized power rule of differentiation, we are used to write, that is dy by dx, which is equal to n into, that is power into the given f of x raised to the power n minus 1 into d by dx of f of x. See, by using this generalized power rule of differentiation, we can also differentiate the given sum of E square with respect to alpha, with respect to beta also. So first we are going to take the partial derivative with respect to alpha. So here if you get the partial derivative with respect to alpha, then it is the derivative of sum of Ey square divided by d alpha, that is equal to n into, that is 2 into sum of function f of x, which is equal to here y minus alpha hat minus beta hat x raised to the power n minus 1, so it is 2 minus 1 into the derivative of f of x, the derivative of f of x here, the derivative with respect to alpha, so it will be minus 1. So if you go for multiplying minus 1 into 2, which is equal to minus 2 sum of y minus alpha hat minus beta hat x. See, we can open this particular bracket. So since here we can consider beta hat is the constant, and accordingly we are rearranging this particular form equation, that is minus 2 sum of y plus, see, minus minus will become plus, so plus 2 sum of alpha hat plus 2 sum of beta hat and x. See, we can equate with the 0 in such a way, it is minus sum of y plus 2 n alpha hat plus 2 beta hat sum of x, which is equal to 0. So on rearranging here, we can write 2 sum of y, which is equal to 2 into n into alpha hat plus 2 beta hat sum of x. Okay. Now see, 2 is common here, so divide the both side of the equation by using 2, so it will become sum of y is equal to, then here 2 will be cancelled out, so it is n into alpha hat plus beta hat sum of x. So I am denoting this is equation number 1. Similarly, we are also going to take the partial derivative with respect to beta hat also. Since earlier we considered the partial derivative with respect to alpha hat, if you take the partial derivative with respect to beta hat, see here, again it will become the d by sum of E square by, we are going to differentiate partially with respect to beta hat, which is equal to 2 into sum of function, which is y minus alpha hat minus beta hat x raised to the power 2 minus 1 into, see, with respect to beta hat, so it will be, beta hat will be minus 1 into x, which is equal to minus x. Then if you multiply 2 into minus x, it will become, see, minus 2 sum is here, so it will be sum of x, then within the bracket term is already there, power 2 minus 1, which will become 1, so power is not, if it is 1, then it is normally not written. So minus 2 sum of, if you go for open this particular bracket, so it will become minus 2 sum of xy, then minus minus will become plus, so 2 alpha hat sum of x plus minus minus will become plus 2 into beta hat sum of x into x, which will become x square, which is equal to 0. Now by rearranging, we can rewrite it is 2 sum of xy, taking other things into the left side, so right side, so it will become, see, 2 into sum of 2 into alpha hat sum of x plus 2 beta hat sum of x square. See, 2 is common here. I am going to divide both sides of the equation by using 2. Then it will become sum of xy, then alpha hat sum of x plus beta hat sum of x square. This is, we are denoting in terms of equation 2. So considering these two equations, that is the normal equation, see, regression equation on y on x, that is y is equal to alpha plus beta x. See, for calculating y on x, the normal equations which we are already calculated the earlier slide, that is sum of y is equal to n into alpha hat plus beta hat sum of x. This is the equation number 1 which we are already derived here. And the second equation, that is sum of xy, which is equal to alpha hat sum of x plus beta hat sum of x square. So these are the two equations which is generally used. This is generally popularly known as, it is the normal equations for the regression analysis or regression equation. Okay. Now, the similar way you can also derive the regression equation x on y, that is x is equal to alpha plus beta y. If you go for deriving the same, then it will be just like so instead of sum of y, it will become sum of x, which is equal to n into alpha hat plus beta hat sum of x. Instead of x, it will become sum of y. Then sum of xy, which is as it is, then alpha hat into sum of x, it will become sum of y here, and plus beta hat sum of x square, here it will become sum of y square. So these are the two normal equations, or it is the normal equations for the regression analysis. By using these normal equations, we can calculate the unknown value of alpha hat and beta hat. Now, see, these are the two equations. By using these two equations, how we can calculate alpha hat and beta hat, that we want to know, especially for calculating or predicting the value of dependent variable by using the independent variable. For that, see, this is the simultaneous equation model. So considering the first equation, I am going to use the elimination method here, so that we can calculate the value of one variable here. The equation 1 which I am going to multiply, see, here I am going to eliminate the alpha hat, so that we can calculate the beta hat. So equation 1 is multiplied by sum of x. So if you go for multiply with the sum of x, then equation 1 will become sum of x into sum of y, then n into alpha hat into sum of x plus beta hat sum of x into sum of x, which will become sum of x square. Okay, this is considering equation number 3. Similarly, equation 2 also, because I want to make the coefficient of the alpha hat same, so that we can eliminate the variable. So here the second equation, that is sum of xy, which I am going to multiply by using n. So here it will become n into sum of xy, which is equal to n into alpha hat sum of x plus then n into beta hat sum of x square. Now considering the equation 3 and equation 4 here, see, both I have written here, I am going to subtract equation number 4 from equation number 3. See here, then how it will be? The sum of x into sum of y minus n into sum of xy, I have written here. These two terms will be cancelled out. See, n into alpha hat sum of x, both are common here. So if you are going to subtract it, it will be cancelled out. Then what is remaining here? It is beta hat sum of x square minus n into beta hat sum of x square. Okay. So here beta hat is common, so I am going to take into the outside. So what is remaining here? Sum of x into sum of y minus n into sum of xy. Beta hat I am going to take into the outside. Then what is remaining here? It is sum of x square, then minus n into sum of x square. It is sum of x whole square. It is minus n into sum of x square. I am going to isolate for beta hat, then it will become, see, this term will goes to the left side and to the denominator side. So it is sum of x into sum of y minus n into sum of xy. This will become the numerator, and the denominator term, it will be sum of x whole square minus n into sum of x square. See, by rearranging numerator and denominator by using the multiplying with the minus 1, and accordingly we are going to rearrange, then this equation will become n into sum of xy minus sum of x into sum of y divided by n into sum of x square minus sum of x whole square. So this is the formula for calculating the value of beta hat. Okay. So when you are going to calculate the beta hat, Then the next step we want to calculate the alpha hat also. So since we have given the two normal equations here, see we are going to calculate the alpha hat by eliminating beta hat here, since it is a simultaneous equation model. See the equation 1 I am going to multiply with sum of x square. So here sum of x is sum of x square here. So first equation I am going to multiply by using sum of x square. So it will become sum of y into sum of x square, which is equal to n into alpha hat into sum of x square plus beta hat sum of x into sum of x square. So this is the I am denoting in terms of equation number 3. Then the second equation I am going to multiply by using sum of x. So it will become, see, sum of x into sum of xy, which is equal to alpha hat sum of x into sum of x, which will become sum of x square, plus beta into sum of x square is already there. Now considering the equation number 3 and 4, I am just to rewritten here. See, I am going to subtract the equation number 4 from equation number 3. So here it will become, see, sum of y into sum of x square minus sum of x into sum of xy, which is equal to, see, these two terms will be cancelled out. Since it is equal, these two terms will be cancelled out. What is remaining here? N into alpha hat into sum of x square minus alpha hat into sum of x square. Since here, see, alpha hat is common here, so I am going to rewrite this particular equation in the form of sum of y into sum of x square minus sum of x into sum of xy, which is equal to alpha hat is common. I am going to take into the outside. Then what is remaining here? N into sum of x square minus, then what is remaining here? Sum of x whole square. Okay. Now I am isolating for alpha hat. Then it will become sum of y into sum of x square minus sum of x into sum of xy, which is in the numerator side, and the denominator side, see, it will be n into sum of x square minus sum of x whole square. Okay. So this is the, in this way you can calculate the value for the alpha hat also. Now see, we are going to consider some of the numerical examples here. See, we have given the value of x and y. We want to calculate two regression equations from the given following data. So we know the regression equations on y on x and x on y, both we want to calculate here. The first we are going to calculate the regression equation of y on x. So this is the formula, this is the normal equations which is we are already derived earlier. So here we want sum of y, sum of x, sum of xy, sum of x plus sum of x also, sum of x square also. So that we want to calculate from given actual value of x and y here. So the x is here 6, 2, 10, 4, 8. The sum of x is equal to 8, and the sum of y, which I have added here together, which is equal to 40. Then x square, I am going to square it, 6 square which is 36, 2 square which is equal to 4, 10 square which is 100, and so on, and summed all these values, which is the sum of x square, which is equal to 220. And then sum of y square, see, y square, 9 square which is 81, 11 square which is 121, and so on, and added together all these values, it is sum of y square which is equal to 340. Then x and y I have multiplied here, 6 into 9 which is 54, 2 into 11 which is 22, and accordingly the remaining values also, and the sum of xy which is equal to 214. Now by using this regression equation, see, I am going to substitute all these values here. So sum of y which is equal to 40, which is equal to how many observations here? We have a 5 observations, so n is equal to 5. 5 into alpha hat plus beta hat. See, sum of x, what is sum of x? Which is 30 into beta hat. This is equation number 1. And the equation number 2, which is sum of xy, which is 214, which is equal to alpha hat into sum of x. What is sum of x? Which is 30 into alpha hat plus then sum of x square, which is 220 beta hat. So this is our normal equation, equation number 1 and equation number 2. I am going to rewrite here. Then after that, here, this is a simultaneous equation with the two unknowns here, that is alpha hat and beta hat. We want to calculate the value of alpha hat and beta hat, and accordingly we can formulate, the regression equations. Now, see, if you multiply, I am going to use the elimination method here. So first I am going to eliminate here alpha so that the coefficient will be the same. I am going to multiply the equation number 1 into 6 so that the coefficient will become the same. So the equation 1 will become, see, it is 6 into 40 which is 240, which is equal to 5 into 6 which is 30 alpha plus 30 into 6 which is 180 alpha beta hat, which I am denoting in terms of equation number 3. Now from the equation number 1 and 3, see, I am going to subtract together, then it will become 200, we have at equation number 3 also, equation number 4 also. This is equation number 3 and this is equation number 4. Now by using, I am going to subtract the equation number 3 and equation number 2. So consider here 240 minus 240, which is equal to minus 26. 30 alpha hat will be cancelled out. 220 minus 180, then alpha beta hat, so which is equal to 40 beta hat. So now beta hat is equal to minus 26 divided by 40, which is equal to minus 0.65. Similarly, after getting the beta hat, then beta hat is equal to minus 0.65. I am going to substitute in the equation number 1. So that equation number 1 will become 40 is equal to 5 into alpha hat plus 30 into beta hat. What is the beta hat value? Which is minus 0.65. So it will become, see, 40 is equal to 5 alpha hat plus 30 into minus 0.65, which will become minus 19.5. Now I am going to isolate for alpha, taking this term into the right side, so it will become plus 19.5. So 40 plus 19.5, which is equal to 59.5, which is equal to 5 alpha hat. Alpha hat is equal to, taking 5, dividing both sides of the equation by using the 5, then it will become 59.5 divided by 5, which is equal to 11.9. Since we are calculated the alpha hat and beta hat, now we can form the regression equation y on x, which is equal to y is equal to alpha hat plus beta hat x. Since alpha hat, which is equal to 11.5, I am substituting here minus beta. Beta value is minus, so it is minus 0.65x. So this is the regression equation y on x. Now after calculating regression equation y on x, we also want to calculate from the given data, that is x on y as well. Since x on y, which is equal to x is equal to alpha hat plus beta hat y. So this is the normal equation which is used for calculating the regression equation x on y. So here all the values which we are already calculated in the previous slide. So I am just going to substitute here. See what is here, sum of x is equal to, which is 30, number of observation, that is equal to 5 alpha hat plus then beta hat into sum of y. What is sum of y? Sum of y is equal to 40. So 40 beta hat, this is equation number 1. Then sum of xy, which is equal to 214, equal to alpha hat sum of y. What is sum of y? Which is 40 alpha hat plus then sum of y square. Sum of y square is equal to 340 beta hat. Okay. So this is the equation number 2. Now considering these two equations, we want to calculate the value of alpha hat and beta hat also. So this is the simultaneous equation with the two unknown alpha hat and beta hat. We want to use the elimination method. First I am going to eliminate here the alpha hat. So for that I want to make the coefficient same. So the first equation I am going to multiply with 8, so that the coefficient will become 5 into 8, which is equal to 40, so that we can go for the elimination method of alpha hat. Now see here, the equation 1 will become 8 into 30, which is 240, which is equal to 5 into 8, which is 40 plus 40 into 8, which is 320 beta hat. This is the equation number 3. And from considering the equation number 3 and equation number 2, see both I have written here, I am going to subtract. Then 214 minus 240, which is equal to minus 26, which is equal to this 40 alpha hat and 40 alpha hat will be cancelled out. 340 beta hat and 320 beta hat, which is equal to 20 beta hat. So here beta hat is equal to minus 26 minus 20, which is equal to minus 1.3, which is minus 1.3. Since beta hat is already estimated here, you just substitute the value of beta hat on the equation number 1 or 2. I am substituting here in the equation number 1. So equation number 1 is 30, which is equal to 5 alpha hat plus 40 into, instead of beta hat I am substituting here, it is minus 1.3. It will become, if you go for multiply these two terms by opening the bracket, so it will become, see, 40 into minus 1.3, which is equal to minus 52. Then taking minus 52 into the left side, so it will become plus 52. So 30 plus 52, which is equal to 5 alpha hat. Then it will become 82, which is equal to 5 alpha hat, and alpha hat is equal to 82 divided by 5, which is equal to 16.4. Since we are calculated alpha hat and beta hat, now we can formulate the regression equation x on y, that is x is equal to alpha plus beta y. So here alpha is equal to 16.4 minus the beta value, which is minus 1.3 y. Okay, this is the regression equation on x on y. So we calculated here both the regression equation y on x as well as the regression equation x on y as well. Now we are going to consider one more example. See, after investigation, it has been found that the demand for textbook in the school depending upon the number of students in the school. See, below the given figure on the sales of textbook of 5 schools in the year 2020-24, see the number of students which are also given here. See, this is the table, number of students in thousands and the sales textbook in 100, both the information given here. What we want to do, we want to fit a linear regression equation of y on x. So y here is the dependent variable and x is the independent variable by using the least square method. And we also want to estimate or we want to predict the sales of the year of 2026 of school P based upon the information that is given value of x, that is 100. Okay, 100 students, assuming that the same relationship is true. So here first we want to calculate the regression equation y on x, then we will go for the estimating the value of y given the value of x as well. So I have written here the schools A, B, C, D, E and the value of x and the sum of x I have already estimated here. Sum of x is equal to 70 plus 75 plus 80 plus 60 plus 90, which is equal to 375. Y I have also added together, so sum of y is equal to 141.7 and x square I have squared here and accordingly summed it, so it is sum of x square which is equal to 28,625. The y also I have squared, so it is y square. I think that y square there is no need to calculate. See, after that, because since we are calculating it is y on x, there is no need of y square. I have just went through multiplying x and y because sum of x, y is necessary. So x and y I have multiplied here, that is 70 into 25.2 which is equal to 1762.64 and accordingly the remaining values I have already calculated here and summed together sum of x, y which is equal to 10,849. Now, see, instead of using the normal equation which I have already explained in the last example, here I am going to use, see, this is the normal equation for calculating the, the regression lines or regression equation. So, sum of y which is equal to n into alpha hat plus beta hat into sum of x, and the second equation also. Rather than using directly by using this normal equation, we have already estimated the alpha hat and beta hat values, this which we have already derived earlier slides. Now I have just taking that particular formula and substituting these values on this particular formulas. In that way also you can calculate the alpha hat as well as the beta hat. See, first I am going to calculate here alpha hat which is equal to sum of y into sum of x square minus sum of x into sum of xy divided by n into sum of x square minus sum of x whole square. Okay. Now here sum of y, what is sum of y, which is 141.7 into sum of x square which is 28,625 minus sum of x 375, then sum of xy which is 10,849 whole divided by n into, we have a 5 observation, so it is 5 into sum of x square which is equal to 28,625 minus sum of x is equal to 375 square. Okay. Now, if you multiply these two terms, so it will become 4056,162.5 minus if you multiply these two terms, it will become 4068,375 whole divided by 5 into 28,625 will become 143,125 minus 375 square which is equal to 1,40,625. If you take the difference between the numerator, then it will become minus 12,212.5 divided by taking the difference between the denominator, it will become 2,500. See, the ratio of these two values, which is nothing but it is the alpha value which is minus 4.885. So this is the alpha value. After calculating the alpha value, we can also calculate the beta value, since I have already given the formula for calculating the beta value, that is n into sum of xy minus sum of x into sum of y whole divided by n into sum of x square minus sum of x whole square. So by everything is already estimated here. So just wants to substitute here n into, we have 5 into what is sum of xy, which is 10,849 minus, see, sum of x and sum of y. Sum of x is equal to 375 into 141.7 divided by, see, n into sum of x square, that is 5 into 28,625 minus sum of x square which is equal to 375 square. If you multiply these two terms, then it will become 54,245, and if you multiply these two terms, it will become 53,137.5. Then if you multiply 5 into 28,625, then 143,125. 375 square, it is 14,000, 1 lakh 40,625. The difference between the numerator, which is equal to 1,000, 1100, 1107.5. The difference between the denominator term, which is 2500. And if you take the ratio between these two, which is equal to 0.443. Now see, we have already calculated the alpha value as well as the beta value. See, alpha hat is equal to minus 4.885 and beta hat, which is equal to 0.443. We want to calculate, a regression equation y on x, that is the fit linear regression equation y on x by using the least square method. So it is equal to y is equal to alpha hat plus beta hat x. Just wants to substitute the values here, which we are already calculated earlier. So y is equal to, here instead of alpha hat I am substituting minus 4.885 plus what is beta hat, which is equal to 0.443x. So this is the regression equation y on x, regression equation y on x. See, this was one of our question, that is we wants to calculate the linear regression y on x. After calculating a regression regression equation, we want to estimate the sales of school P in the year 2026 with the given value of x. See, we are already said that the regression equations are actually used to estimate or predict the value of dependent variable with the given value of independent variable. See, the same case we are addressing here. We have given the value of x, that is non-value of x. Based upon the non-value of x, we are going to calculate the unknown value of y, that is independent variable. So here what we are going to do, we are going to just substitute the value of x is equal to 100 here in this given regression equation. So it will become, see, what is the regression equation? Y is equal to minus 4.885 plus 0.443 x. So instead of x I am going to substitute it is 100. If you multiply these two terms, it will become 44.3. 100 is not there, it is 44.3. Then 44.3 minus 4.885, which will become 39.415. So here the y value, which is equal to 39.415, which we can interpret in such a way that, see, the estimated textbook sales for the school P in 2026, it is 2026, it is not 2006, it is 2026, are 39.41500 approximately. That means approximately 3,941.5 books are required in 2026 for the school P. So in this way, with the given value of x, we can calculate the value of y. So that's why we are already said that the regression equation can be utilized for predicting the value of y based upon the given value of x. So that's all about the regression equation by using the normal equations. In the next class, next lecture, we are going to discuss the regression equation by taking the deviation from its mean and assumed mean also. So we'll see in the next lecture. Thank you.